Hello, this is Bradley Van Dam, and I will be doing Chapter 27, for, Exam 27, and I will be doing questions 27.1.1 through 1.4. So let's get started. So for the first problem, we're given an electron with charge negative 1.6 times 10 to the 19th. 19 coulombs, and it given us a velocity of the electron, so v equals 2.2 times 10 to the 5th meters per second through a uniform magnetic field of 1.25. That points in the positive y direction. So I'll say in positive y. Oh, and I forgot my calculator, so 1 second. Okay. Calculator. So positive y, velocity of the electron lies in the xy plane, directed 40 degrees in the, where is that? 40 degrees in the positive x. So I'll say in positive x and 50 degrees in the positive y. And then those two just sum up to 90 degrees. So the question is asking us to find the magnitude of the force on the electron. So we can use the equation, excuse me, F equals, and what's the magnitude? So in this case, we're going to do magnitude of Q, so even though it's negative, times the cross product of velocity vector times our magnetic field vector. So we're looking for F. So we are given, we're given the charge, we were given, did they say the velocity? Okay, yes, they gave us those two angles. So, so what we can do is we can put in our values 1.6 times 10 to the negative 19th times, that's just absolute value, but I just changed it to positive here, times the cross product. So we know it's in the positive y. First, let me actually just do a little illustration. So x, this is how I like to think about it, a little triangle, x, y, z. So whenever you're doing cross product, so x cross y is z, z cross x is y, and then if you go in the opposite direction, then it's negative. So I'll just say, for this case, it's positive going clockwise. So we are given the velocity, and we are given the magnetic field. Okay, so in positive y, so in this case, we're going to do the velocity 2.20 times 10 to the 5th times the magnetic field 1.25. And in this case, we're going to have to do sine of, in the positive y, we have to correspond those into the positive y. So 1.25, so I'll just say a little cross just to stay with that notation. So 1.25 times, actually, well, I'll just say 1.25 sine, and then 90 minus that angle that the velocity vector is going in the positive y. We do 90 minus because it's perpendicular, so 90 minus 50, which is essentially just 40. I'll just rewrite it like that. And so we're going to get this expression here. So let's write that out. 1.6 times 10 to the negative 19th of the charge times 2.2 times 10 to the 5th times 1.25 sine of 40 It's supposed to be, I believe it's supposed to be a 3. Let me see if I mess anything up here. 1.6, yes. If I sign, I get the values, -19, 5, yep. Okay. So, it's supposed to be 3.28 times 10 to the -14th newtons. And again, that's the reason we're doing negating that charge values, because it's going to be absolute values. So that is going to be our answer for part A. And part B says find the direction of the magnetic force on the electron. So let's see. Dun, 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 dun. Okay. Yep. So we have in this case, the problem we have x, y, so yeah, so we do positive. Okay, yeah, so this is essentially, that was that guy right there. So that even though it was 50 for positive y, that essentially is that x value. So we do the y cross x, which is going to be in the negative z. So in this case, clockwise is positive. So if I were to do x cross y, it would be z. But since we're doing y cross x, it's negative z. So for part B, I can just say in the negative z direction. And that is the direction of the magnetic force on the electron. So question 1.2. 1.2. So charged particle moving with the presence of magnetic field of 0.75 T. Yeah, field experiences a magnetic force of magnitude 2 points, so Fm. I'll just M there as well. Actually, sorry, that's not. Okay, no, that is, yeah. So, sorry, I lost my train of thought. So, yep, 2.5 times 10 to the negative 10th newtons. It gives us the velocity. So moving at 1.95 times 10 to the 5th meters per second in it says 36-degree angle. So I'll say 36. I'll just say 36 degrees to B. And it wants us to find the magnitude of the charge on the particle. So in this case, we're looking for Q. So we're going to be using, we're going to be using a similar equation. So F equals Q VB sine theta. So I guess we can just say that guy 36 is theta. And we're looking for Q. So we can rearrange this. So we just divide all this over. So Q equals F over VB sine of theta. And we are given all of the respective values. So we can just plug everything in. Times 10 and negative 15. Oh, it's negative 10, sorry. For force. Velocity 1.95 times 10 to the 5th multiplied by B, so 0.75, times sine of that angle, theta, 36 degrees. Let's do that out. Uh-oh. Nope. Oh wait, I'll just put in parentheses. And then we get 2.91. I'll just round again to 3. So 2.91 times 10 to the negative 15th. And since we're solving for charge, that's in coulombs, so C. That is part C done, and 1.2 was just that question. Oop, hello. There we go, yeah. On to 1.3. Okay, so 1.3 is a two-parter. So for part D and E, it says a particle with a charge, so Q equals, and this time it's a positive charge of 3.20 times 10 to the negative 19th coulombs, with a velocity in the x direction, so Vx equals 3.75 times 10 to the 5th meters per second, in the presence of a magnetic field with only a z component. So let's see how we want to do this. Yeah, so B only has z. So I'll say B only has a z hat component. And it says the magnetic force of the particle is magnetic force, so Fm as a vector form, because they give us the direction it's going into. So 2.10 times 10 to the negative 15th newtons, and that is in the negative y direction. And so the question wants us to find the B, but since it only has the z value, so we're looking for looking for B of z hat. So we're going to use similar, actually, yeah, let's use this equation up here. So Fm equals, this time it's not absolute value of Q, but since it's positive, it's just going to stay there. So then we have B of x hat cross product of, and then it says it only has a z component for the magnetic field, so B of z, and we're looking for magnetic field. And the magnetic, the force, I'm sorry, what is it? The magnetic force on the particle, it says it's positive, but it's in the negative y direction. So we're actually going to say negative F. And we are looking for this guy. So let's rearrange the equation. I'm actually going to, I won't say F of M. I'll just symbolize the different directions they're going. So I'll just say F of y hat, but we know this is magnetic force. Oops, sorry. So negative F of y hat. So let's look for this. So we still have the cross product. So let's just divide Q over equals, and then still the cross product of the two vectors. Okay, I'm looking for this guy. And so let's see. Okay, so again, going back to this chart right here, so since we're doing the cross product of the velocity and the magnetic field, and this is in the x direction, this is the z direction, so x cross z is negative y, so we can rewrite this as negative F of y hat divided by Q equals, and then just group these guys together since they're, if you do the cross product for that, so we do V, and I'll just put them together. Actually, yeah, so it's going to be negative, so let's just put the negative inside there. Negative VB, and that's in the y direction. And then now that we have them both in the same direction, we can make our last transformation, still solving for B, So we can do B is equal to this guy divided by negative velocity. So I'll just do F, Q, and then negative V. Awesome. Okay, so that is